and today's talk is going to be a bit different from what I normally do. Like last year I had a very technical talk, but this year I decided to do something inspired by an event I had at work at one point, and the title is called Troubleshooting the Fudge Out of It, which means kind of insisting on troubleshooting an issue that we found in the system until we actually get to the root cause. So these are some links about me, so my blog, my GitHub, and so on. And I will start with what the fudge. So what are we basically trying to do? We are working on a piece of software, and a very weird behavior can be observed in our system. We don't know why it happened, so the root cause is not very obvious, but we need to figure out why this issue occurred. How can we do that, and who should do that? Well, many times I see in teams that only developers are the people who will investigate the root cause of an issue. But I'm here today at this conference to tell you that testers should also be involved in this process, simply because we know so much about the systems that we're testing, and we know more about these systems and the integration with other systems, that we can help out the entire team to find the root cause. So it's not going to be just an effort of the development to figure out the root cause, but it should actually be a teamwork process. So we can help out in investigating and finding out why we have this major bug in our system. Where do we usually start? So the first thing is to actually reproduce the issue. We need to make sure that there is an actual issue. We need to start reproducing it, and we need to reproduce it constantly. I've seen certain situations where people are going to say that a bug is random simply because we didn't manage to properly reproduce it. For example, the situation that I was referring to in the beginning, which led me to do this talk, was that I was working at the company, and we were at a backlog grooming session at one point. And we had a bug in the system which was categorized as being random, and it was in the system for 2 years, and nobody had even tried to fix it, nobody looked at it. It was so, everybody was just keeping their distance simply because we had random in the description. So this word was just putting everyone off from trying to look at it. So in this grooming session, somebody mentioned that, oops, we managed to reproduce this issue right now. So now we can actually reproduce it, but only on one machine. On another machine, where we have the exact same piece of software, the issue doesn't reproduce. And I was like, are you sure? Yes. So one of my colleagues tried to reproduce the issue in front of me. So on one machine, they were getting a behavior. On the other machine, it was a totally different behavior. When I looked at how this person tried to reproduce the issue, it was clear they didn't do the exact same thing. They used a different set of data when they were trying to reproduce the same issue. So they weren't working with the exact same variables. Okay, the application deployed there was exactly the same on both machines, but the data that they were inputting into the system was different. So the behavior that occurred was not random at all. Based on a certain type of data, the bug reproduced every single time. It wasn't random at all. The fix was maybe 20-minute fix together with pulling the code from the repo, pushing it back, code review, and so on. Testing was 5 minutes. Okay? So for 2 years, this bug was not fixed simply because somebody categorized it as being random. And that's a shame. And so when we find a bug, we should start with reproducing it and reproducing it consistently. I would say at least 3 times, just because then we have more information and then we have more certainty that this bug really reproduces. Usually when a bug happens, it's because it goes through a certain set of steps in the background, right? So when we're trying to do something as users on our system, in the background, certain lines of code get executed, which means that those steps will happen or will be executed every time we input the same data into the system. Probably. I will tell you why in a moment. So when we're trying to reproduce something, we need to use exactly the same steps as when we initially found the bug, and we need to work with the exact same types of data. Exactly the same types of data. So, if you have special characters, use special characters. You need to know exactly what you're working with. If you couldn't reproduce the issue 3 times, well, there might be some explanations, like maybe you didn't have your coffee this morning and you didn't, you thought you saw something, but you didn't really see it. Well, this is more, like it's a rare situation. The second thing would be that maybe you really didn't use the same type of data. So try to go back to the exact same type of data that you used before. There are some, let's say, environment issues that might lead you to believe that a bug is random. For example, what if at the moment when you were trying to reproduce the issue, there was a load balancer issue, like maybe one of the machines behind your load balancer is not really working properly, and when you try to do something, you hit that exact same machine, but then when you try to reproduce it again, you hit another machine which was working properly. So this is something you can look at. Maybe there was a network glitch. Maybe some hardware issue that occurred right at the time when you tried to do something. Or maybe the database was temporarily unavailable. All of these behaviors might be random, so maybe we are not going to have the same DB lock every time we're going to perform a certain test scenario. But what if we do? Is the impact on our system so high that it is worth investigating even at this level? So do we really need to go into like networking issues or load balancer or DB issues? When we're trying to reproduce the issue, if it's very important and if the behavior that we observe is critical, we really need to dig up until we actually find the root cause. It is very difficult to find issues if they are, like, let's say, in the network, right? Because up to getting there, you need to go through like the software, the commits, the logs, and so on. But if it's a critical bug, we really need to go to that level because we really need to make sure that if these things ever happen again, we don't have a fatal crash of our system or any very bad behavior for our customers. So, is this a new behavior or has it been observed already? If it's a new behavior, then we really need to dig further. If this issue is something that we've previously seen in the system, we might be lucky because maybe somebody already fixed this bug previously. And it just reoccurred because maybe for some reason someone else overrode the code without knowing what the new code was supposed to do. So if we know what the issue was, we need to, track it. We need to see who changed the code, why they changed it. We need to communicate within the team to make sure that these kind of situations don't happen again. We don't want to see the same bug again simply because somebody was not careful enough. If the issue was not fixed before, at least we have some leads. So somebody already probably started investigating why this issue occurred. So we don't have to start from zero. We can already see some information that somebody else collected before us. If it's a newly discovered issue, so something that nobody else saw, then we need to, actually start asking the questions and we need to properly investigate. What are some of the things we can look at? So let's say we have 2 different environments. And on one environment, the issue reproduces, and on the other environment, it doesn't. By the way, do I have a bug in my time system? All right. OK, so what we can look at between the 2 environments where, on one environment we reproduce the issue, on the other we don't. We can look at, here I wrote down 5 components, but of course there can be more. We can look at build versions for our software. We can look at build configurations, like flags and all kinds of settings that are specific to certain machines. We can look at dependency version. So if our system interacts with other systems, we can look at the versions of that dependency that we have in both environments. We can also look at the configurations for those dependencies because, as you know, people who have a service or software in general, they will test different things on different environments, and maybe the setting is not always the same. Of course, we can also look at hardware configurations if these first parameters are not something that are going to help us. So here I kind of built a, let's say, table that kind of helps to figure out exactly where the issue lies. So let's say that on these 2 environments, everything is the same except for our build version. So if our build that we deployed to these 2 different environments are different, then we know that the issue is probably on the latest code that we pushed. Because let's say that that's the environment where the issue reproduces. So if that's the case, if it's in our build, then we can take a look at commits, for example. We can check who committed what code. We can discuss, by the way, discussion is a key part of doing this. If we are going to try to investigate something without talking to anyone else in the team, well, we're screwed. It's a team effort. Everybody commits code, even for testing, even for development. So we all need to be aware of what is happening. So if it's in the build and we can trace it back to the commit, then we can, fix it and address it there. This would be a very easy thing to do. What about if everything is the same on both environments except for, let's say, certain configurations and flags? Well, it's pretty easy to figure out whether those are to blame, because if we are going to change these configurations so that they are the same on both machines, we can know for sure that that is what is causing the issue. If we're changing the configuration on the machine where the issue is happening to the configurations of the machine where the issue is not happening, then we know that it's a configuration issue, and then again we can take it up with the developers to see what happened there and how we can actually fix it. If it's a dependency issue, so if another service we're working with is causing our issue, whether it's their build or their configuration, this might be a bit trickier, because let's say we have an external dependency. Maybe we're using a library that someone else is building, and we don't really have access to their code, and those teams that are working on that are not a part of our team. What we can do here is just revert to a previous version of the dependency so that we actually have the software working. If we really need something that they have in the latest version, then we can just reach out to the people who are developing the dependency and make them aware about what the new build is causing to other systems. Many times people who build software that is a dependency to another team are not aware of certain issues that we face as consumers of that service. So it's very important to feed back to the people who are writing that code. Of course, if the teams who are developing this dependency is within our company, it's much easier to do. It will take, discussions about, well, they don't have time to fix it right now, they can do it, it's not on their roadmap, and so on. So again, as a short-term solution, we can revert to a previous version. However, if our software really needs that piece of code that they are developing, and if our functionality is very crucial to the business, then the discussion will be a bit different, because we need them, they are our dependency, and because we're working for the same company, they kind of need to help us out here. So again, it's going to be a inter-team work, where everybody's trying to fix an issue that nobody really wants there. And again, we're helping the dependency to figure out, how to deal with their consumers in the future, and how this code that they're pushing might affect other teams. If we have, let's say, a hardware configuration, which is the only thing that is different between the environments, well, we might have a hardware limitation, so we should just switch hardwares and try something else. Logs are our best friend, like Captain's log, where he enters everything. Just like that, our logs should provide us useful information when we're trying to investigate something. Some teams don't really have logs. So for some teams, when their system is doing something, pardon my language, crappy, they don't know what is happening there, because they don't have any information stored in any log. It's like a black box. They have no idea what that software is doing. We need to have logs. So implementing logs, which is a development task, should be part of the definition of done of the new features that we're developing. Simply because we need to be aware what is happening in that software that we're delivering to our customers. Of course, we can have many logs. So we can, at one point, we might even get lost in looking at the logs. We might not even know what we're really looking for, but it's a good idea to start looking there. Especially if we have, let's say, a timestamp when the issue occurred, we can more easily look into the logs and see, some error there. Sometimes the errors will kind of trigger in our memory something that maybe somebody committed a few days ago, like maybe somebody worked on a feature and then we see an exception is in a certain class, and we know exactly who to go and talk to, because we know that that person implemented the class which is throwing an exception. If we don't have anything like that, it's really difficult to figure out what is happening. Sometimes we have issues in the browser. So maybe we're trying to click on something and the click is not working, or we are, I don't know, redirected to a blank page. What can we do there? Can we use any tools to investigate? Well, the cheapest, meaning it's a free tool, is the so-called Firebug, or as it's now called, DevTools. Basically, we have in our browser embedded a tool that can show us requests that are flowing from the time that we clicked on something. We have like a console tab where we can see like JavaScript errors. We also have cookies where we can see whether a certain cookie value impacts our page. And we can also see like maybe the JS files are missing. So all of this information is really easy for us to find if we are looking in these so-called dev tools. A very important part, as I said, in finding out the issue is talking out loud and trying to provide some information or some hints to the people who are doing the debugging. Maybe it's not going to be us who is going to do the troubleshooting, but if we have an idea, like if we have any kind of useful information, or maybe not even useful, if something pops into our mind, we should just let the people investigating know what it was all about. For example, this happened to me recently. So we had a bug in the system. We didn't know exactly what it was all about, where it came from, but I remembered that a colleague who was on holiday was working on something the days before she left on holiday. And I just, we were in a discussion with several developers, and I said, oh, wouldn't it be related to this, this, this? And I was there with two developers, and one of them, I saw him literally rolling his eyes like, what is she talking about, But the other developer who was sitting next to me started thinking, maybe what I said was right. Maybe it might be a possible clue to find out what happened. So no idea and no opinion is stupid or bad or anything like that. Any thought that you present to the people who are doing the investigation might lead them to the right track, might make them think about, they're thinking about something that leads to something else and so on. So maybe this helps. It doesn't necessarily, but at least you tried. And at least you know that if it's not what you said, that's a lead that you can just put aside, and you don't need to investigate that further. There are some times when we just can't find a solution. We don't know what the root cause was. And many times people will just, they're trying to go down a path. They're trying to figure out something on a certain path. They think that is the solution. But even when they find out that that wasn't the solution, they will just keep on going on that path. And I would say in this case, if you've seen that you spent 3 days trying to investigate on that path, just try to go back. Try something else. Try to backtrack and get out of that, try a different path. Maybe you were actually going on the wrong path. And there's nothing bad about that. So at least you've made sure that what you've tried is not the root cause. It's fine. Now we have more information. Now we know we shouldn't do that. Now we can try something else, and this way we can actually figure out what is the right path and actually find the root cause of our issue. And I am done just on time, and thank you very much.
Thank you very much. Thank you, Corina. So we have a few questions, right? So I help you. I'll help you reading out. So what do you think about testers taking on the role of company troubleshooters, essentially being technical support?
I encourage you to do this. So, as a tester, we're not just about clicking on a button and writing test cases. We can be so much more valuable by doing so many other things in the company. And this is one of the things we can do. We can actually help with this. I'm also somebody who looks at customer tickets, so I'm also trying to figure out why our customers are encountering issues. And this kind of work is actually fun. So it's really nice to investigate and to find out, it's like a puzzle that we need to solve. So please do that. You don't necessarily have to think about yourself as technical support, but as doing something different apart from your normal day-to-day work, which involves creating and running tests and so on.
Good, thank you. The next one, it's not easy to understand the root causes when system is used by lots of people. Maybe you face conflict, but you don't know what others do. Any suggestion on that one?
Talk to the people, you know? Like, I encourage everyone in teams to communicate. Even if you're in the same team, I've seen many times that testers don't talk to developers. I've seen many teams that are working on their own, you know, on their own thing, and they're not communicating with someone else. If you are in a large system, like if you have 20 teams working together, if you don't know what the other person does, how are you going to actually deliver the product to the customers? Like, you need to have an understanding of what happens across the whole you know, software development team group, not just your own. So here I just say, talk it out with the people, maybe have some kind of, you know, regular meetups where you show what you developed, they can show you what they developed, so it's all about, you know, communicating.
Okay, thank you. And we still have time, another one. So what do you think about testers having developer knowledge, knowing the code deeper, especially in agile teams? Does it help or does it introduce bias?
Okay, thank you for this question. So I am a person who knows code. I'm not an expert at code, so I couldn't write your next AI tool, but at least I have a better understanding of what code the developers are committing, which means I can actually, in many times, not all the time of course, make, let's say, informed decision whether this code is going to be good or not. I have seen, and I've went through certain situations where people were just pushing code, expecting me to test it, but even by looking at the code that they wrote, I realized that wasn't something I should even bother testing because I would just waste my time. So having developer knowledge or coding knowledge is very useful for actually understanding what we're trying to deliver to the customers, what the developers are doing, but also for me it helps to write efficient tests. I write a lot of automation, so I'm trying to write code that is reusable, that is easy to read, short tests, maintainable tests, and so on. So I truly encourage you to learn some code if you're part of the development team, because it also helps you, and it helps with your understanding of the product and with your personal development.
Thank you very much. We still have time, so one more maybe. What if the product is on logging on info level, but to understand what happened, you would need logging level on debug?
So if it's just a matter of, you know, turning the setting from info to debug, that's something you can actually do in your test environments. Nobody's stopping you from doing that. However, if the developers are not logging the right thing, well, create tasks for them in Jira and make them work on that. I've seen this happen a lot of times, so we don't have all the required information in the logs. But we can actually prioritize to do that, because if we really need that information, we need a source for it. So we can put it as being part of our development process. It can be part of the definition